We are going to look into few solutions of GATE questions between 2010 and 2020. In this lecture, you will be seeing on questions related to fiber length and fiber fineness. Not the complete questions, but most of the questions between 2010 and 2020 we'll look here. This is the question related to fiber length. This is GATE 2014, question 18. The fiber parameter that cannot be obtained from bar sorter diagram. For this, you should have an understanding of the parameters that you can find out of bar sorter instrument and other instruments too, so that you can have a concrete answer. So the things, parameters that are listed are A, mean length, effective length, span length, and model length. So let us see the parameters that you usually find out of bar sorter instrument. They are maximum length, mean length, dispersion, and upper quartile length or effective length, and short fiber percentage are the usual things that you will find. But out of that diagram, you can also find model length. But you usually do not find in this experiment. From that sorted diagram, model length can be found out. Then next is the parameters that you can find out of fibrograph, that are 2.5% span length, 50% span length, and uniformity ratio. So from this, you can find the answer that is span length. So bar sorter, you cannot find span length, whereas in fibrogram, only in electronic type of instruments, photoelectric principle uses span length as its parameter. Next, we will see this fiber length related question. This question is also related to bar sorter. GATE 2016, question 19. A comb sorter diagram of cotton fibers is shown below. They have given the sorter diagram. Usual notations that are used in the sorter diagram are different, but they have given here different notations. I want you to refer bar sorter, sorter diagram analysis, so that you can find the answer easily. Usually in A dash is the length, upper quartile length given in this diagram. So A dash, they have given OA. OA is 0.25 of OC. So it is the upper quarter. So this indicates that the effective length gives the upper quarter of the major group. So it is the answer here is A dash. For better understanding on sorter diagram, you need to refer sorter diagram analysis video. A dash as per this diagram is your effective length. Let us see the next question in GATE 2020, question 11. This is similar to the question which we saw earlier. In this also, the bar sorter diagram parameter that cannot be found is asked. Mean length, dispersion, and model length can be found using bar sorter. Uniformity ratio is a parameter that you will find out of HVA instrument. So the answer is uniformity ratio. The next question is also related to bar sorter instrument. GATE 2010, question 37. The effective length of cotton is 21 mm. Lower quartile length. The lower quartile length is given. The effective length is to be found out, and the dispersion is given. Let us see the question for solving. This is the question, fiber length related question, and the question is related to effective length of cotton with 21 mm lower quartile length and 25% dispersion. So effective length of lower quartile length dispersion are all related to bar sorter instrument, and you have to refer to bar sorter video for before solving this problem. So in that the answers given are 4 choices. We have to find the right answer. So what are the things that are given? So lower quartile length is given and dispersion is given. So lower quartile length is 21 and dispersion is 25%. 21 mm is your lower quartile length. For this, we need to know on bar sorter, as I already said. So in bar sorter, we have these terms: upper quartile length, and it is denoted as LL dash in the sorter diagram. For the lower quartile length, it is MM dash, and the difference between the upper and lower quartile length is dispersion. And you have the formula for dispersion. NL dash by LL dash into 100. So the difference between upper and lower quartile expressed as a percentage of upper quartile length is your dispersion. So we know NL dash is nothing but your LL dash minus MM dash divided by LL dash into 100. So this is the formula that we have from the sorted diagram analysis. Next we'll go into the solution. So you can write the same. So now we are substituting for we have lower quartile length as 21 mm dash is your lower quartile length, and the dispersion we have it as 25%. So we'll substitute first. We are substituting for dispersion. 25 is equal to LL dash minus MM dash divided by LL dash into 100. Then 25 is equal to LL dash minus MM dash. We are substituting the lower quartile length, which is 21 divided by LL dash into 100. Next, you are bringing the 100 to the left hand side. So it becomes 25 by 100 is equal to LL dash minus 25. 21 divided by LL dash. Next, 25 divided by 100 is 0.25. Next, 0.25 into LL dash. On the right hand side, in the denominator LL dash is there. You bring that to the left hand side. So it becomes 0.25 LL dash is equal to LL dash minus 21. Now you bring 21 to the left hand side. So it becomes positive. 21 is equal to LL dash minus, because 0.25 LL dash is brought to the right hand side, so it becomes negative. Next, 21 is equal to LL dash. You take out and insert the brackets. LL dash into 1 minus 0.25. Now 21 is equal to 0.75 into LL dash. So LL dash is equal to 21 divided by 0.075. So it is the same. Now you get LL dash is equal to 28, which is nothing but 21 divided by 0.75. LL dash is nothing but your effective length. So effective length is equal to 28 mm, because mm dash was in mm. Here we get LL dash also in mm. So among the choices, the right answer is 28 mm. D is the right answer for this question. The next question related to fiber length, as with regard to HVA instrument, it is 2.5% span length and uniformity ratio are given, and you have to find the 50% span length. The question you can see here, the given data are 2.5% span length and uniformity ratio. Uniformity ratio in percentage and 2.5% span length is 30 mm. You can see fibrograph HVA. You can refer these things for knowing the formula. The only formula and simple formula to find out the value for 50% span length is uniformity ratio formula. Uniformity ratio is equal to 50% span length divided by 2.5% span length into 100. So substituting, now let us look into the solution. We know the values already for uniformity ratio and 2.5% span length. Substituting for uniformity ratio, you have substituted 45%. Next, substituting for 2.5% span length, which is 30 mm, and then solving, you get 45 divided by 100 is equal to 50% span length divided by 30. Then 45 divided by 100 is 0.45, which is equal to 50% span length divided by 30. Then uh, bringing 30 to the left hand side, 0.45 into 30 is equal to 50% span length, or 50% span length is equal to 0.45 into 30, which is equal to 13.5. So the span length value is 50% span length value is 13.5 mm, and the key given for this is 13 to 14. Any value if you write between 13 to 14, it will be right, because you may round it off. That is why they have given like that. So this is the key. Similarly, with the same formula, if 50% span length and uniform ratio is given, also similarly substitute and find out. It is a very simple value. 50% span length is equal to 2.5% span length into 0.45. That's all. That is the answer here. Thank you. The next question related to fiber fineness. GATE 2016, question 46. The question asked is, you have to find surface area divided by volume, and the unit is per mm, for a circular polyester fiber of 1.5 linear fineness and 1.38 gram per cc density. Let us see the given details. So this is the question, and the two data that are given are fiber linear, which is 1.5, which means it is 1.5 gram per 9,000 meters. Next is density, which is given 1.38 gram per cc. We have to be very careful with the unit. The thing that we have to find in this question is surface area per unit volume. Surface area divided by volume of the circular polyester fiber. So they have mentioned it as circular. So we can assume the fiber to be circular. Next, the formula that we need to know to find the required things are density, which is mass by volume, and fiber density is fiber weight by fiber volume, and fiber density is equal to fiber weight divided by fiber volume. We put the formula for fiber volume, which is fiber cross sectional area into length. Only these things we need to know. So let us go into the solution for this problem. So in this we know that fiber linear is 1.5. From the fiber linear we are converting the unit from gram per 9,000 meters to gram per cc or gram per centimeter. The fiber weight in gram per 9,000 meters is 1.5. 1.5 gram for 9,000 meters. So we are finding the weight for 1 centimeter of fiber. So weight in grams for 1 centimeter, so which is equal to 1.5 divided by 9,000 into 100 to convert into centimeter. So you get 1.667467 into 1.6667 into 10 power minus 6. This is the grams of fiber for 1 centimeter. That is 1 centimeter weighs this much weight. So next we'll go into the solution. So we have already seen the formula. Fiber density is equal to fiber weight by fiber cross sectional area. So now let us see the data. So fiber density is fiber weight by fiber cross sectional area. We know the formula pi r square, which is pi d square by 4. We are putting that here, and we are separating and writing the right hand side fiber weight by fiber length into 1 by pi r square or pi d square by 4. Next is fiber weight by fiber length is your fiber linear density. We are putting that in gram per centimeter, which we have already found. So we can put fiber density is equal to fiber linear density in gram per centimeter, which we have found. So I'm putting it as 0.0167. I can put it here. Let us substitute the value again. So it is 1.6667 into 10 power minus 6, which we have found. We have fiber weight in gram per 1 centimeter. We are doing this because we should convert this in all the units into centimeters so that we can cut the values. If the dimensions are different, then we cannot substitute it right. So here is the same. Next, we can substitute the value for density. Fiber density is 1.38. So the same. Next. So now we are rewriting. We are bringing the d square, which is in the denominator in the right hand side, to the left hand side, and we are bringing 1.38 to the right hand side denominator. So it is like this. And next, d square is equal to the value divided by the same, it is given. So now substituting for all the values, we will get the answer. So after putting square root, we'll get this answer. D is equal to 0.00124004, which the unit is in centimeters. So we can convert into mm because in the question surface area per unit volume is asked in per mm. So we are converting this into mm. Now let us come to surface area and volume. The question asked is surface area divided by volume. Surface area is pi d into L. So cross-sectional area into length is your surface area. So pi d is the circumference into length. Divided by pi d square by 4 into L, which is the cross-sectional area. Now we by cancelling, we get surface area by volume is equal to 4 by d. Now we are substituting for d from this for in mm. So the value of d is 0.012405. So 4 by d, the answer is surface area by volume is 322.5. And the key given for this is 322 to 323. If you put any value as answer, then you would have got it right. So this is how we solve this problem. This is a general knowledge question like type. You only need to know about the fineness of fiber. GATE 2017 question 39. The number of fibers in a t-shirt is to be found out. Let us see the given data. So this is the question. The given data is entered here with the units that have been given. So the fiber decitex is given 1.4 decitex. The cotton fiber density is given in kg per meter cube 1520. Cotton fiber length 30 mm. Weight of t-shirt 0.15 kgs. So the only thing we need to know for this problem is the definition for decitex. Decitex is nothing but the number of grams in 10,000 meters of fiber. Grams present in 10,000 meters of fiber. So I have written the same here, grams in 10,000 meters. So we'll convert this into gram per centimeter. So the first conversion here is, so gram per 10,000 meters to gram per centimeter. This is the conversion. This 1.4 divided by 10,000 into 100. The 100 is also in the denominator. So you will get the weight in gram per centimeter. This simple thing is enough. So the cotton fiber density is given. We'll see if it is required. Then cotton fiber length, it is given as 30 mm. Now we'll convert it into centimeter because we have converted the fiber weight per length in gram per centimeter. So we'll convert this into a centimeter. And weight of t-shirt is given, which we will convert into grams. So it is 150 grams. So we need to find the number of fibers present in 150 grams of t-shirt. So the fiber, then linear density is given, the length of the fiber is given, and the weight of the t-shirt is given. So it is a very simple problem, just a logical understanding. So we'll go to the solution. So we have here weight of one fiber. We have to find weight of one fiber so that we can find the number of fibers in this weight. So weight of one fiber is weight of length of 30 mm, which is because one fiber is of length 30 mm. So we have to find the weight of the fiber of 30 mm length. So we know the weight of the fiber of 3 centimeter. So we have weight of 1 centimeter of fiber we will find first, then we will go to weight for 3 centimeter, weight of fiber for 1 centimeter, which we have already found gram per centimeter. Weight of the fiber, the fineness of the fiber is given and we have in gram per 10,000 meters, we have converted that to gram per centimeter. So weight of 1 centimeter of fiber is this value. I have put it in the 10 power minus 6, 1.4 into 10 power minus 6. So now we'll find the length of 3 centimeter of fiber, which is 3 into this value. Then we will get, this is nothing but the weight of one fiber or 3 centimeter fiber is 4.2. 3 into 1.4 is 4.2 into 10 power minus 6 grams. So from this, we have got the weight of one fiber. So we have got the weight of one fiber, which is of 3 centimeter length. So weight of the t-shirt given is 150 grams. So we will see, so weight of t-shirt divided by weight of one fiber, we will get the number of fibers in the t-shirt, which is 150 divided by 4.2 into 10 power minus 6, which we have got this value. But in the question it is asked in multiples of 10 power 6. So we will write this answer as multiples of 10 power 6, which is 35.7 into 10 power 6 for converting to decimals. So this is the weight of this is the number of fibers present in a t-shirt of 150 gram. So the key given for this is any answer between 35 to 37 is right. So the exact answer is 35.71. So this is how we solve this problem. This question, GATE 2014 question 49, is related to vibroscopic method of fiber fineness. The question asked is, you have to, for determination of fiber fineness using this method, what are all taken into account? So, and it is related to frequency. You apply in the vibroscoping method, you apply a certain frequency to a fiber of length L, which is kept under a tension. And when the natural frequency of the material matches with the applied frequency, you get resonance, and that is using that the fineness of the fiber is found out. So the formula used is given here. You have tension, mass per unit length is found out, which is your fineness. L is the length between the clamps, which is the fiber length, and F is the natural frequency. So the answer is tensile strength of the specimen. Even without the formula, by understanding this, we can find that the answer is tensile strength, which is not related to fineness.